This is a review of the lab we did to determine the heat capacity of a metal. Now, we have learned the following formula. Delta H equals mass times Cp times delta T. Delta H can be measured in joules or calories. Mass measured in grams. Specific heat is a property that determines how much energy it takes to change the temperature of something. And here's our delta T, final minus initial. Now we know that the heat gained must be equal to heat lost. Now, let's go over into the lab because I have some stuff boiling right now. Okay? First of all, I have 100 grams of water in this calorimeter. Let's look at the temperature of it. The initial temperature of the water looks to be about 23 degrees Celsius. Okay? Now, inside this beaker right here, I have some brass. Now, the brass has been boiling at this temperature. Now, I'm here in the middle of the summer. It's a beautiful day outside. The atmospheric pressure definitely determines the boiling point of water. The higher the atmospheric pressure, the higher the boiling point. And it looks like we have some high atmospheric pressure today because the water happens to be boiling at, looks like, 103 degrees Celsius. Okay? So here's our initial temperature of the metal, which happens to be brass. What I'm going to do right now is I'm going to take that brass metal out of here and I am going to put it in this container of water. And let's see what happens when the energy is transferred. Let's stir it. And it looks like it went up to about, 30 degrees Celsius. Okay, so now let's go back. And let's see. Looks like it's reaching equilibrium. I think I was pretty right when we said around 30 degrees Celsius. Okay, it's gone down now, but it's become stable at 28 degrees Celsius. Okay, now the last thing we have to do is determine the mass of the metal. Here's the cylinder. And let me dry it off. I wanted the metal in the beaker boiling for a long time so it could reach that boiling point temperature. Don't fall. Woo! And it looks like it's 54.77 grams, 76 grams. Okay, let's come on over here. Mass of metal, 54.77 grams. Okay, initial temperature was 103 degrees Celsius. The mass of the water was 100 grams. The initial temperature of the water was 23 degrees Celsius. The final temperature when we mixed them together was 27 degrees Celsius. Now what happened? The water gained and the metal lost heat. And they have to be equal. So, the water, delta H, is equal to the mass, 100 grams, times the CP of water, 1 calorie per gram degree Celsius, times delta T. What's delta T? Final minus initial. 27 minus 23 is 4 degrees Celsius. That means we have 400 calories of heat were absorbed by the water. An endothermic process. What does that mean? That means that the metal must have what? Lost 400 calories of heat. So we have again M times Cp times delta T. Now, if heat gained is positive 400, what's heat lost? Negative 400 calories is equal to the mass. What did we find out was the mass of the metal? 54.77 grams. Times heat capacity. Isn't that what we're trying to find? Okay. Times delta T. Final minus initial. What was the final temperature of the metal? The final temperature was 27 degrees. Minus 103. What's 27 minus 103? Negative what? I'm going to have to do this. No, I don't have to do it on the calculator. Negative 76 degrees, I think. Negative 76 degrees Celsius. Now look at this. We're going to have to take, now, divide by this, divide by that. Let's see what we get when we do that. We know we're going to have a negative divided by a negative, so that's going to make it a positive. So we're going to have negative 400 divided by 54.77 divided by negative 76, and we get 0.096 calories per gram degrees Celsius. Here's just a review on how to find the specific heat of a metal.